monitoring system, which is coming to the first design of our idea. Firstly, the problem statement. In our daily growing lifestyle, health is a very big issue, and when if I am staying outside my home, taking care of my parents' health and monitoring them, it's very difficult. And by the aging time, the elderly people are getting more and more health issues, and it is not getting measured at early stage, which leads to more severe conditions. And also, we have two modules, which is the first health monitoring system, which uses SpO2, heart rate, and then body temperature, which is basic parameters of a human body, which shows various types of changes in a human body related to health, mental health, and everything. And then we have the accident and fall detection system, which detects when a person gets fall. This was basically designed for elderly people, because at their age, when they fall, it gets very if there is no one at home, it gets very difficult for anyone to contact, or the chances of getting emergency help is very less. So we are overcoming these two problems in our solution and combining it. As I can say that our model is a very compact version of what is available in the market and going on. So coming to the next part, with the introduction, telling about it is a continuous health monitoring system which uses IoT. The data is sent to the cloud. It uses machine learning, and then it will analyze the health risk and then send an alert message to the respected emergency numbers or the connected devices. Then for the novelty of the project, it combines multi-parameters of biomedical and fall detection in a single wearable platform, which is not available in the market completely. So moving on to the literature survey part. Firstly, we have analyzed various type of papers on based on health monitoring system and the fall detection system. So talking about the first paper, which was on the health monitoring system, it had the health parameters related, but there was no accuracy on the accuracy of the multiple sensors was not so very good. And also there was no fault detection is present there. And when we took the second reference, it was a pulse oximeter based IoT system for SpO2 and heart rate. But this system has mainly one sensor which was used, and we have combined two more other sensors.
So just one second. Next time when you prepare this slide, include the year and the first author.
Okay, sure.
Okay, so that it will be easier to.
Okay, while I'm writing the reference.
Yes.
Okay, sir. Okay.
Sir, reference number দিয়েছে apart from that ওটা দেওয়া better হবে
At a glance we can
Yeah.
see the key হচ্ছে and how old the
Yes,
is. That's very important in the research.
Yes.
Please note it down for the final sense.
Yes. Okay. So the third was the ESP-based health monitoring system. It was a very good system because it can do decision making on the cloud data, and then same it had the drawback of not being so incorporated with the other sensors and things present. And then we have the fourth paper, which was the accelerometer-based detection threshold value, in which it detects only the fall detection of the person. As I have also researched, there is a fall detection belt present for elderly people, but it's just for the fall detection. So it doesn't contain any other. So integrating that with every other health measures also is a good part. Then with the activity and fall detection using wearable motion sensors was also the same thing, with telling about the fall detection and everything. Then moving on to the components which we have used in our project. First one is the ESP32 microcontroller, which is a basic microcontroller to process the data and everything. Then we have a MAX30102 sensor, which measures heart rate and SpO2. Then we have the temperature sensor MAX30205, which measures the temperature. And then we have MPU6050, which is a 3-axis accelerometer. Then we have charging module, boost converter, and then lithium battery. Then for the software, we are integrating our taken data in ThinkSpeed right now, and then the data is getting transmitted to that, and then it will send a alert message with the circuit digest cloud, which we have completed for our fall detection module firstly. So moving on to with the methodology of the system, explaining that firstly the safety monitoring system, starting with the safety monitoring is about the fault detection. So we have used SBU 6050 sensors, and the ESP is the main controller of the module. The biometric, these they will sensor the safe limits of the activation of fault detection. Like if the person has, can you move to next step?
Do you have an Arduino board also, or only ESP32?
ESP.
Only ESP.
So sir, they are explaining with the flowchart only. Firstly, by start, there is a wearable device in our hands. It will first initialize the health monitoring sensors, which is the MAX3010 to MAX30205, and after that, initializing that, it will measure the heart rate, SpO2 and temperature. As we know that our normal heart rate is from 50 to 100 to 120, it will fluctuate, and for the SpO2, it should be greater than 90 degrees. For the temperature, it should be 35 degrees Celsius or either ways. And so if the person wearing the glove detects that if the person has upward the threshold value, it will send a message alert to the registered number, and it will also show in the cloud app which will be created. And then if it doesn't detect any type of uncasualty, then it will move to the fault detection module. And then that NPU 6050 will initialize, and it will detect for the fall, which is the acceleration. It will detect the 2.3 G, means when we have normal hands we move, it's from 0 to 1 and 1.3. But we have, if someone falls, the intensity is very high, so we have kept that in mind. And then it will detect the emergency condition and then send alert and the cloud part. And if it doesn't sense that person has fall or it's a normal moving condition, then it will go again to the heart rate monitoring system, and then.
So in the normal condition, you are not storing any data.
No, sorry. In normal condition also it's getting stored, but
In cloud.
Yes. So everything is getting stored in cloud. If he will show this to you.
You are having 10 minutes time.
Yes. So moving on with the block diagram, which will be explained.
Already you are crossing the time. So
Good morning, sir. Good morning, ma'am. So this is the block diagram for our project. Here we are using, as already she told, that we are ESP32 microcontroller with the sensors for SpO2, heart rate, and the fault detection sensor as the accelerometer. So going to circuit diagram. This is the circuit diagram for our project. Here we using the I2C communication protocol for the connection. Just because we are connecting the SDA pin and SCA pin with the ESP32 from all the sensors, and the ground and the input is going to the sensors.
Sir, because time is short, it's better to show the data.
Yes.
Yeah, show the data.
Sir, these are the readings.
Just go through the slides
Yes,
very fast.
sir, these are the readings which we have taken from the things speak.
Okay.
And then these are the confusion and future scope in which we are aiming to create expression on the mental health also, because by age the mental health is also a very big factor, and implementing machine learning and various technologies, combining it for also elderly people and people who are sick or cannot move from.
There are some digital surveys where among these over the project there are many survey or many project already happened. So we utilize those things.
No, not this one.
Okay, you continue.
Here the project is mainly many companies or many group already did this project on ESP32, any Arduino, Uno, and many things, but they only target to only operation or any fault detection. But we are targeting all both, as we monitor the health of a transformer time to time. With if there is any fault, they will detect it and give a notification to the operator.
Good afternoon, sir. My name is Ishani Shah. Here to present the circuit diagram of our project. In this circuit diagram,
we are mainly targeting the overload fault of the transformer, and also we are all continuously taking the graph and checking whether the transformer is under normal condition or not. Here a AC source of 230 volts is connected to the single phase transformer which rating is 1 kVA. Here in the primary side we get 230 volt AC, and in the secondary side we get approximately 150 to 120 volt of AC in the secondary side. From here we are connecting a current measurement and a voltage measurement, from which we are continuously taking the voltage data and the current data, and we can see the graph through this scope.